Welcome back to the Real Number System. In this video, we're going to continue our discussion of percents. So let's get started. Applications with percents usually fall into one of three different forms. Sometimes we're asked to find the percent of a number. Or we're asked to find what percent one number is of another. Or the third form, we might be asked to find a number when the percent of that number is known. Look at example 5. A house sells for $92,000. It requires a 20% down payment. We want to know what is the amount of the down payment. Well, 20% is 20 over 100. Percent, remember, means per 100. We're going to set up a proportion, so equals 100 represents our whole, and the house sold for $92,000. That is also our whole, so it goes in the denominator. We're looking for the part, the down payment, so the x, the part, goes on top. To solve proportions, we can cross multiply. 20 times 92,000, I used my scratch paper and I got 1,840,000. 100 times x, divide both sides by 100, and 1,840,000 divided by 100 is $18,400 for the down payment. Look at example 6. If Alberto has 45 correct answers on an 80-question test, what percent of his answers are correct? On the left side of our proportion, we have our part 45 correct out of our whole 80. On the right side, we're looking for the percent, the part, so it goes on top, and the whole 100 goes in the denominator. 45 times 100 is 4,500, and 80 times x. Divide both sides by 80. And to review dividing with decimals, I'm going to come off to the side and divide 80 into 4,500. 80 goes into 450 5 times with 50 left. Bring down your 0. 80 goes into 500 6 times with 20 left. Now there's understood to be a decimal place behind the last 0 in 4,500, so I write my decimal place. And remember to line up your decimal place in your quotient and your dividend. Write a 0 to the right of the decimal place and bring that 0 down. 80 goes into 200 2 times with 40 left. Write another 0 to the right and bring down that 0. 80 goes into 400 5 times, and finally we have none left. So our percent here is 56.25%. Let's look at example 7. 42% of the parents of the school district are employed at a local university. If the number of parents employed by the university is 168, that's our part. How many parents are in the school district? That's the whole that we're looking for. 42% is 42 out of 100 equals, our part is 168, it goes on top, divided by the whole, which is x, what we're looking for, and the whole goes into the denominator because the 100, the whole, is in the denominator on the left. Cross multiply, 42 times x is 42x, and 100 times 168 is 16,800. Divide both sides by 42, use your scratch paper to divide, and you get that x is 400. So there are 400 parents in the school district. Look at example 8. Skis at a sports store near Humphreys Summit are on sale for $476. If the original price was $560, what percent were they discounted? First, I need to know the dollar amount that they were discounted. So I take the original price, $560, and I subtract the sale price, which gives me $84. Then I'm going to set up a proportion. My part is 84 and my whole is 560. On the right side of my proportion, I'm looking for the percent, the part, so that goes in the numerator, over 100% total in the denominator. Cross multiply, 84 times 100 is 8,400, and 560 times x is 560x. Divide both sides by 560, and when you use your scratch paper to divide, you get that x is 15%. So the skis were discounted for 15%. Mental math is very helpful with percents, so let's look at two strategies. First, we can use fraction equivalents. Now, knowing these fraction equivalents by heart is going to help you on some problems, because sometimes mental math is easier with fractions than trying to multiply decimals in your head. So some common percents and their fraction equivalents are these. 25% is the same thing as 1/4. 25% is 25 over 100, which simplifies to 1/4. 50% is the same thing as 1/2. 75% is the same thing as 3/4. And you can see 4 other common percents on that table. Again, be sure that you know these percents and their fraction equivalents. Example 9 asks us to use equivalent fractions to mentally calculate our percents. 50% of 80. Well, 50% is half, so half of 80 is 40. Look at part B. 66 2/3% of 90. Well, the fraction equivalent for 66 2/3 is 2/3. So I multiplied 2/3 times 90, or 90 over 1. Multiply the numerators. 2 times 90 is 180, and 3 times 1 is 3. 180 divided by 3 is 60. Another method that we can use to mentally calculate with percents is using a known percent. So sometimes we may not know the exact percent of something, but we know a close percent of it. For instance, let's suppose I want to find 55% of 62. Well, I know a close percent to 55%. That's 50% of 62. That fraction equivalent, 50% is half of 62, so that's 31. I also can find 10% of 62. The fraction equivalent for 10% is 1/10. So 1/10 of 62, or 62 over 1, multiply the numerators and we get 62. Multiply the denominators, 10 times 1 is 10. So 62 over 10, or 62/10, would be 6.2. Now, I need 55%. Well, 5% is half of 10%, so half of 6.2 would be 3.1. So to find 55%, I add the 50% and the 5%, so 31 plus 3.1, and that gives me 34.1. Let's look at part B. 15% of 90. Well, 10% of 90, that's 1/10 of 90, which is 9. Next, let's find 5% of 90. Well, 5% of 90, that's half of 10%, so half of 9 is 4.5. Add these two numbers together, 9 plus 4.5, that gives us 13.5. Estimations with percents can help us decide whether or not our answers are reasonable. For instance, if I want to estimate 148% of 500, well, 148% is close to 150%. So 100% of 500 is 500. 50% of 500, or half of 500, is 250. So I add these two together, and that gives me about 750. Or in example 12, Laura wants to buy a blouse that's originally priced at $26.50. The blouse is now on sale for 40%, and she has $17 in her wallet. Now she wonders if she has enough cash. So how can we figure this out? We're going to ignore the sales tax for now. First, I'm going to round. I can find 40% of 25 easier than 40% of 26.50. So I'm going to round 26.50 to $25. Well, 10% of 25 would be 1/10 of 25, or 25 over 10, which is 2.5. 40% then is 4 times 2.5, which would be 10. And so our original price is $26.50 minus $10 gives us $16.50. Now we're rounding, so I'm wondering, this is kind of close. Would Laura really have enough money? 40% of $26.50 is going to be a greater discount than 40% of $25. In other words, we're going to be taking off more than $10 discount. And so yes, Laura does have enough money.